Hello, and welcome back to another video on math and science problems. Today's video, we will be discussing the Fibonacci sequence. So, what is the Fibonacci sequence? The Fibonacci sequence pretty much states that there is a series of numbers where the previous two numbers before that number, when added together will always equal the number ahead of it. So, for example, if we start off with 0 and 1, 0 plus 1 is 1. So the next number in the sequence will be 1. Redoing the same step that we just did. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. And 8 plus 13 is equal to 21. And in the Fibonacci sequence, this continues to go on by stating that the two previous numbers will always add up to the next number. And so this can be seen as the function and slash or equation as this. F of n, where n is any number, where n is a number, is equal to f times n minus 1 plus, so we're adding f of n minus 2. So, using our previous examples, say if we take the number, let's take the number 3, for example. So 3 is equal to n in this case. So if we have 3 minus 1, which is equal to 2. And then we also have 3 right here. 3 minus 2 is equal to 1. And we add these two numbers together, 2 and 1. We get the number 3. And this can be seen because when we have this number 3 right here, we are subtracting 1 and then we are subtracting 2. And we're subtracting 1 because of this integer, 2. And then we're subtracting 2 because of this integer, which is 1. And due to us subtracting by 1 and also subtracting by 2, the opposite of subtraction is addition. So when we add these two differences, we get the sum of 3, which is why the Fibonacci sequence makes sense. So we can use the Fibonacci sequence to find mostly all of the numbers that comes from the sequence. So if you wanted to continue this list, 13 plus 21 is equal to 34. And 21 plus 34 is equal to 55. So let's trace our steps back. The Fibonacci sequence can be seen throughout the world in many different ways. Through this equation right here, we can have an example such as a shell. So say we take one of these little squares as one unit, and we wrap around it. Then we wrap around, we do it twice, and then it's 3 times, and then it turns into 4, and then 5, and then 6. So this is a adequate example of what the Fibonacci sequence really is. You start off with 1, and through this previous one, it doubles from the addition. Then you add, then you add, then you add, and then you add. So through the Fibonacci sequence, we can see the patterns and how the different things can work. And this ties in to the golden ratio. So the golden ratio, I'll touch on this slightly so we can discuss this in another video. The golden ratio is pretty much saying that if you have a line and you cut it into two, let's say I want to cut it right here, a little bit over half, that the first part will be A and this will be B. That when you add A plus B and you divide by A, you'll be left with B. So this can be seen as A plus B divided by A will always equal to B. So since the A's cross out, the B is only left. So if this whole line is worth 10, and let's say A is 6 and B is 4, 6 plus 4 is 10. And then since the 6's cancel out, you'd be left with B, which is 4. So the Fibonacci sequence slightly connects with the golden ratio because it is able to track that sequence of the addition and kind of a little bit of the division. So throughout the Fibonacci sequence, we can see this pattern appear in shells, in ocean life, through the doubling sequence of the circular figure. We can also see this in architecture through how people will be able to design buildings and such. So through this equation, f of n is equal to f of n minus 1 plus f of n minus 2. You will always be able to double the previous number, and it will always equal the number of heads. So 0 plus 1 equals to 1, 1 plus 1 is equal to 2, 1 plus 3 is equal to 3, 2 plus 3 is equal to 5, 3 plus 5 is equal to 8, 5 plus 8 is equal to 13, 8 plus 13 is equal to 21, and so much forth. So, through this Fibonacci sequence, we can see how this formula works and why it works. Because when we take a number, like we mentioned before, such as 3, we're subtracting 1 prior, and then we're subtracting 2 prior. So when we're subtracting 2 prior, we're getting the 2 before numbers that we already had to equal the number that we started with. So like in our previous example, we had 3. So 3 minus 1 was equal to 2, which is the one previous number before, which is set minus 1. And then we also have 3 minus 2, which is equal to 1, which is 2 numbers prior before it. And so once we add these 2 numbers prior, we will always get the number that we started with, set the equation. And this is how this picture correlates throughout the Fibonacci sequence. Thank you so much for tuning in to the Fibonacci sequence. Please like, share, and subscribe. And I hope you gain a deeper understanding of the Fibonacci sequence through how to get to the Fibonacci sequence through the equation shown, some examples through the picture, and how it connects to the golden ratio. Please make sure to like, share, and subscribe, and I will see you all on the next video. Take care.